Ford has been behind the curve when it comes to innovation in the booming electric vehicle landscape so far, playing second fiddle to ground-up EV startups like Tesla and Rivian. But with cars like the Mustang Mach E slowly but surely gaining market share, the Blue Oval company is gearing up to disrupt the EV market with their magnet-free electric motor. But what exactly is a magnet-free electric motor? Before answering that, let us tell you all about the more commonplace regular EV motor and what makes it tick. There's no denying that the electric motors that power most EVs today are marvels of engineering, but these are marvels that unfortunately aren't without some environmental baggage. The underlying architecture utilizes permanent magnet synchronous motors, which rely on the interaction between carefully arranged permanent magnets on the rotor, which is the spinning part, and electromagnets on the stator, which remains stationary to create torque. This magnetic process is incredibly efficient at converting electrical energy into motion, a key reason why modern EVs boast impressive range and performance compared to their gas-guzzling counterparts. The permanent magnets themselves are made up of rare earth elements like neodymium and dysprosium. Mining these elements can be a dirty business, often linked to environmental degradation, water pollution, and even human rights abuses in some parts of the world. Imagine vast landscapes stripped bare, with mining operations spewing dust and contaminants into the air and water. These pollutants can harm ecosystems and local communities that rely on clean air and water for survival. Additionally, the complex manufacturing processes involved in refining and shaping these magnets also require significant energy consumption, further adding to the environmental cost. Power plants burning fossil fuels to meet this energy demand pump greenhouse gases into the atmosphere, further contributing to climate change. Another potential concern with PMSMs is their reliance on copper for the windings in the stator. While copper is generally a good environmental choice due to its high recyclability, the sheer amount of copper needed for high-powered EV motors can strain the resource. Let's take Tesla's flagship, for example. Just one Model S motor can contain up to 40 kilograms of copper. Extracting this much copper requires large-scale mining operations that can disrupt ecosystems and pollute the surrounding area, and processing of this copper ore also requires significant energy and can release harmful chemicals into the environment. This is where Ford has made a major breakthrough and has partnered up with ZF to invent an all-new type of EV motor. But why does the world need such a thing? Well, the devil is in the details. As mentioned earlier, conventional electric vehicle motors heavily rely on permanent magnets, specifically those containing rare earth elements. These elements are anything but rare in terms of abundance on Earth, but their extraction can be a dirty business. Mining operations can disrupt ecosystems, pollute waterways, and even contribute to human rights abuses in some parts of the world. Additionally, the supply chain for these elements is often complex and geographically concentrated, making it vulnerable to disruptions. This is where ZF's innovation comes into play, as their magnet-free motor design eliminates the need for rare earth elements altogether. Their approach centers around a novel inductive transmitter cleverly integrated within the motor's rotor. This integration not only reduces the overall size of the motor, but also allows it to deliver performance on par with conventional permanent magnet synchronous motors. The benefit of ZF's design extend far beyond just size reduction. By eliminating rare earth elements, the environmental impact of motor production is significantly reduced. Imagine a future where EV production doesn't rely on mining practices that disrupt ecosystems and pollute the environment. Not only that, but by removing these elements from the equation, Ford has also minimized the potential for supply chain disruptions, ensuring a more stable and reliable source of materials for EV production, leading to a more robust and sustainable industry in the long run. However, it's important to acknowledge that this technology is still relatively new. While ZF claims its design matches the performance of PMSMs, real-world testing and large-scale production will be crucial in verifying these claims. Additionally, the cost-effectiveness of this new design compared to traditional PMSMs also needs to be evaluated. If the magnet-free motor proves to be significantly more expensive to produce in the future, its widespread adoption might come into question. Despite these potential challenges, the collaboration between Ford and ZF represents a significant leap forward in the EV industry. Their magnet-free motor design offers a compelling alternative to traditional PMSMs, promising a future of cleaner production practices and a more secure supply chain for electric vehicles. As the technology matures and production costs are evaluated, we can expect to see this innovation play a major role in shaping the future of sustainable transportation. Now, you might be wondering what makes Ford's magnet-free electric motor tick. The answer lies in a groundbreaking technology developed by their ZF Friedrichshafen AG, a German multinational automotive supplier. The heart of this innovation is the in-rotor inductive excited synchronous motor, or I2SM for short. Unlike conventional permanent magnet synchronous motors that rely on physical brushes or rings to energize the rotor's magnet, magnets, the i2SM employs a far more elegant and efficient solution: contactless induction. This is where ZF's magic happens. Imagine an inductive transmitter nestled within the core of the rotor. This transmitter transmits electrical energy wirelessly through a process called electromagnetic induction. Think of it like magic, but based on well-understood good old physics. The transmitter creates a rapidly oscillating magnetic field that, in turn, induces an electric current in the surrounding conductive material, the rotor itself. This induced current in the rotor then interacts with the stator's magnetic field, generating torque and propelling the motor. The beauty of this design lies in its simplicity and efficiency. By eliminating external brushes or rings which can wear out and create friction, the i2SM boasts several key advantages. Firstly, it achieves a significant reduction in the motor's axial length. Imagine a more compact and streamlined motor design, leading to potential benefits for vehicle packaging and weight distribution. Secondly, the absence of these physical contacts eliminates friction losses, leading to improved overall motor efficiency. This translates to a more efficient conversion of electrical energy into mechanical power, ultimately extending the range of an electric vehicle. But the benefits go beyond just compactness and efficiency. The i2SM's lack of permanent magnets unlocks a whole new level of eco-friendliness. As mentioned earlier, traditional PMSMs rely heavily on rare earth elements for their magnet composition. Mining these elements can be a dirty business, often linked to environmental degradation and human rights concerns. The i2SM, by eliminating the need for these elements altogether, offers a much greener alternative. Imagine a future where EV production boasts a significantly reduced environmental footprint. Furthermore, the contactless design of the i2SM paves the way for increased durability. With fewer moving parts and the elimination of wear-prone components like brushes, this motor design promises a longer lifespan and potentially lower maintenance costs. Imagine an EV motor that requires less frequent servicing, contributing to a more hassle-free ownership experience. The significance of ZF's i2SM technology extends far beyond the immediate benefits for Ford's electric vehicles. Its emergence signals a crucial shift in the EV industry as a whole, with forecasts suggesting the EV market will reach a staggering $1.1 trillion by 2030. Innovations like the i2SM have the potential to revolutionize the future of electric transportation and also turn the Ford EV division's fortunes around. Here's how these magnet-free motors can contribute to a brighter EV future. Enhanced efficiency. Traditional PMSMs experience energy losses due to heat generation in the permanent magnets. The i2SM, by eliminating these magnets, minimizes heat losses and friction losses associated with brushes. This translates to a more efficient conversion of electrical energy into mechanical power, ultimately extending the driving range of EVs. Imagine traveling further on a single charge, a key factor for consumer adoption of electric vehicles. On top of the environmental and reliability improvements brought forward with modern electric motors, they show hints of bringing forward some performance benefits for future Ford EVs as well. The Blue Oval brand isn't new to putting out some truly ridiculous EVs from time to time. On top of the environmental and reliability improvements brought forward with modern electric motors, they show hints of bringing forward some performance benefits for future Ford EVs as well. Like the record-setting Mustang Mach E 1400, a 1400 horsepower beast that tore up the drag strip. This wasn't just a party trick, it served as a test tube for future electric powertrain technology. The future of Ford EVs might hold even more thrilling possibilities thanks to advancements like integrated switching motor technology. While still under development, this revolutionary motor shows immense promise for exceeding the performance of permanent magnet synchronous motors currently used in most EVs. At higher speeds, the absence of heat-generating magnets in ISSM could lead to a superior performance, and Ford isn't just talking about theoretical possibilities either. They're actively showcasing what electric performance can achieve. Take the Mustang Mach E GT, a production car that puts out a respectable 480 horsepower and rockets from 0 to 60 miles per hour in a blistering 3.8 seconds. This all-electric SUV redefines what performance can look like in a non-traditional segment. Then there's the upcoming F-150 Lightning Platinum, an electric version of America's favorite truck. While details are still emerging, early estimates suggest a 0 to 60 mile per hour time in the mid 4-second range. This would be mind-blowing for a vehicle traditionally known for its towing capacity and ruggedness. Ford is proving that electric power doesn't have to sacrifice the thrill of acceleration or the satisfaction of raw power, and things will only get better once they bring the magnet-free electric motor to market soon. The partnership between Ford and ZF on this magnet-free motor is a significant step forward forward for the electric vehicle industry. It represents a commitment to not only technological innovation, but also environmental responsibility. As other automakers take notice and potentially adopt similar technologies, the environmental impact of EV production has the potential to be significantly reduced, paving the way for a future where clean transportation solutions are not just efficient, but also sustainable. What are your thoughts on Ford's new innovation? Let us know in the comments section, and don't forget to subscribe for more exciting news from the automotive world just like this.